Hello guys, in this video now we're gonna go tell you about the training of GANs. Before going to the training, I want to just give you a quick recap of the components of GANs before moving forward. So this is a discriminator which consists is just like a binary classifier which classify the images real and fake images. This is just a binary classifier which consists of 2D layers and followed by ReLU, and its org is just to classify, and this is just a binary classifier we can use at the end a sigma to determine the class which is real or fake, so this is a discriminator. We just do the binary classification, and this is generator which is a deconvolutions, which do deconvolution means it just upsample from the smaller dimension images to higher dimension images. This is a generator which do upsampling, and this is the our dataset, training dataset. So it consists of we can imagine it consists of 100 images for a simple calculation. So it consists of 100 images. So it is the dataset of 100 images we are considering right now, and after that we are take this is our generator, and this is our random noise vectors which is sampled from Gaussian or uniform distributions, and this is our setup, and we will gonna go learning the how we will train this network. So while training the network means what we are doing really here actually is we are trying to make the generator more capable of generating real looking images that look similar like a training data set. Our main objective is here is take a random noise of 100 dimensions. Let us consider the 100 dimensions from some standard distribution from sampling processes. It's pretty easy. Just take the 100 dimensional vectors from the normal distributions or uniform distribution, and just pass to the decoder, pass to the not a decoder but generator, and it will convert this random vector into images, realistic images which look similar to the images present in the data set. So our main goal here is to make the generators when we give a vectors 100 dimensional or any dimension is we'll considering as 100 dimensions. So when you pass this 100 dimensional vector to the generators, it will have to generate the images which look which resemble the properties of the property and the feature of the images which is present in our dataset. And how can you make the generator give you that such capabilities? I think I want to tell you that generator consists of upsampling layers like con 2D transpose, or you can just use upsampling. So it's just to the opposite of convolution, means it will just from the lower dimension it will just expand the dimension of our images. So and this discriminator is just a classifier, and what we're gonna go do is here is just our main objective is it to train this part. So first of all, let's go from the first step. What we're gonna go do is first of all, in training is we give 120 images. First of all, to train the discriminator, first of all we train the discriminator and then generator. So training can't be happen both at the same time, because it's pretty hard. If you try to train this both networks, it is nearly an impossible task to achieve. So first of all, we take 120 images and we pass to the discriminator, and discriminator learn from the 120 images. In 120 images we give 64 images of real, 64 fake images which is generated by the discriminator. So that's the in the first we are gonna go train on batch. We will apply model dot train on batch this keras future we will gonna go use model train dot we will just use first of all so we are not training these both networks simultaneously. First of all we train the discriminant a little bit better not whole. We'll train the discriminator with 1,000 images we will not train the discriminator with 1,000 images. First of all we just give the 120 images to the discriminator, and discriminator will try to learn the a little bit of aspect of images, because for 120 images it can't learn the much features, so it will become little bit better in classifying the real and fake. And so first of all in training we'll give 64 real images, and 64 real images we will pass. This is the from the real training data set. We'll give 64 images to the discriminator, and discriminator will learn the real data set, and after that we will pass the generated data set. Generated data set 64 64 from here, and discriminator determine the loss loss from this classification it will learn from this 120 images and some 120 images, and it will have some loss because it has some weights so it has some weights, and it has many parameters, nearly a million parameters, more than a million parameters in a typical discriminator. So then when we calculate the discriminator loss, and we will have to backpropagate that loss to the discriminator, and we have to update the weight of discriminator. So while training this first of all we give 120 image to the discriminator and calculate loss, and backpropagate the loss and minimize the losses, and update the weight of discriminator become a little bit of capable of distinguishing between real and fake so after the training of this discriminators we will just this is on train it hasn't we'll use this generator which hasn't been trained right now. So we will our that now the turn of training of generator comes into place. We have just trained for one batch of the discriminator, and the training of a generator started from here. So the discriminator this generator is just a transformation functions. So I want to just give you the little bit of intuition of that. What is generator? A generator is a function which transform this random noise into images into a real looking images. This generator we have to make this as a transformation functions. So transformation functions means it will take some 100 dimensional it will take some 100 dimensional vectors so 100 dimensional vector, and it will convert into it will convert into some transform images which is real looking images, and so which is a real looking image which have certain pixels in it. So this is the main purpose of the discriminator. It will take some vector and transform into real looking images. So we want to learn this transformation function. So as a neural network is a universal function approximator. So it is our main goal is to take some random vectors from the known distribution we have already known, like Gaussian distributions or even a uniform distribution, and just pass to the generator and generator the main work of generator is to transform this random vector into real looking images. So as a whole we want to learn this function. So as a neural network learn function means neural network, what's the main purpose of the neural network? The main purpose of the neural network is to approximate some functions. So as right now generator is trying to learn these transformation functions, which means if we give a random vector, it will convert into the real looking images. So we need the weights here. The generator weights, there are I think millions of weights, millions of parameters. So we have to find the optimal parameters of the generator. There are many parameters. So if we have large number of parameters, we can approximate any functions. This transformation function we can approximate, which can convert a random noise which is sampled from the known distribution, and it will convert into real looking images. So if you have a many variables, like millions of variables, so millions are not a variable but parameters, millions of parameters, so we can learn this function, which this is a function, just a function which will take a random vector and convert into images. So we have to find this f of x, which is also, we can just write g of x because it's generator. So g of z means we have to f of x or g of z. You can just write this f of x function which is gonna go output given the latent vector z, this from which is sample from the distribution, from the prior distribution, and it will, this function take this x as input and it will output some real looking images. So it is multivariable function, so it has a many variable because it has just one parameter. There is just x. Actually the generator has a millions of parameter like x. So it is a pretty complex transformation function. So we want to just learn this function which will take the some vectors and take it at z as in z. This is z, guys. So I will forget that giving the notation. This is z. So this is z, and when you take a z, it will convert into real looking images, which is a set of pixels. So our goal to now is to create this function which is because our neural network will learn the function, approximate the function as close as possible. So if we give some z, it will output some real looking images. So we have to learn the parameters from here. There are millions parameter weight and biases. There are millions of parameters weight and biases. We have to learn these parameters. So guys, and our goal is to update the weight. First of all, we start with the random weights, and we'll keep on making the weight generator weight update and finding the optimal values which will do the work of this function g of z of x, which takes some vector and convert into images. So guys, yeah, how can I make it to happen, to work like this? So first of all, we are training. First of all, we will train the discriminator, guys. Discriminator on 128 images. We'll train the discriminator in 128 images. It become little bit of capable of distinguishing between real and fake images. After it has some loss, and because the model is learning, this discriminator network is learning, discriminator model is learning, so it has some losses, and with this loss it will backpropagate and reduce the loss and become better. So this discriminator become better, relatively better, and after that what we're gonna go do is we will, and this is, we are to train the discriminator work has been done. So for this now, for one batch, this work has been done. So we freeze the weight of discriminator and the training of generator started. So what we'll do is actually while training the generators, we will just we will generate some samples from here. We'll generate some sample from here, and we will give this as a one, first of all, and we'll give as a one level. That what it means. This is a generator which will generate some images because it is not trained, guys. it hasn't been trained, generator hasn't been trained. And first of all listening, generator takes some input and it will generate some random images at initial listening. It's just a noise, just noise. So it will at the first time it hasn't been trained. Generator try to just generate some random images, just a set of pixels, just a noise, so this is just noise. We will some get some noise g of z, which is just a image but not just a noise image. This is nothing. So when we give this noise to the discriminator, easily detect this and the noise and fake image, because it's pretty noise, so it can easily detect this, and because it has trained on 120 images. So at the first time it will just say that it's fake, fake. And guys, we are not giving this data as any while training the discriminator. We are not using this data set, you have to remember it, isn't it? So we are not using this data set, isn't it? We are just while training the generator. Generator training means we will just find out g of z, and this is just random images. And because at initially it can't generate the better quality images, so at first it will just generate some random images. The random images is then passed to the discriminator, and discriminator at the first time and discriminator will say this is a easily can detect this and detect this. Guys, one important tricks we will apply. It's such an interesting concept, so I'm gonna tell you that when you give this generators, this is the image, this is the image, so with the image we give this fake image as label 1, so label 1 means we are we giving this label 1, this fake image, this is a fake image generator whether it is generator, so we give the label as 1 to the discriminators. And so generator image we give label as 1, and this is our input to the networks, and this is our feature, this is our output as we train. This is our feature 1, and this is our y, and this is our x, this is our y, so this is our defined data set. You can just say that, think that like this is y and this is our x, so when you pass this random image to the discriminator, and discriminator will say at the it will say it is false, and give the label as 0, because it has been trained on dataset 120 images. It can really detect this, it can detect this noise easily, and say this is 0, and we are saying this is 1, 1, and discriminator, and we are saying 1, so and there is some loss, because this is the input, input to the network, this is x and y, and there is some loss, because we are saying loss is equal to, just we are using simple formulas in short, y minus y add, there is we are saying this label as 1, but the output from the entire network, this network this composite network which consists of generator network, it was saying 0, z object passing through the discriminator giving y at as 0, so there is some loss, so this is our level, given level 1, and this is the predicted level by the discriminator 0, and we have some loss here 1, this is the loss of the network, composite network, because we are generating samples and passing to the discriminator, and generating some losses, the given label as 1 because we want to fool the discriminator, so we see that this is 1, because we want to train it, so this is given, we are given the label 1, so it has some loss. It will say no, this is a fake images because it has been trained, and we are giving the label as 1, so there is some loss, guys, there is some loss, and we have to minimize the loss of this network, while this is our network now, right now, from there to there, while training the discriminator, the back propagation is from here to here. Just take some images from here and just calculate loss and update the weight of here, so in discriminator training is we just take the images from here and loss and just update the weight of discriminator. That we do in discriminator training is but in training of GANs we start from here this random sample. We sample some z and pass to the generator and we produce g of z, which is images, give the label as 1 and pass to the discriminator and generate some loss and back propagate the loss to the generator is in here loss to the generator here is in. So guys, so while training the generator, the discriminator parameters and all the parameters of discriminator will be freeze. We will not update the parameters. It's constant. This discriminator is just a constant. So there is a loss in the mode network, composite network there. This is a network, isn't it? There is some loss, isn't it? This weight is freeze, isn't it? We can't update the weight of the here, isn't it? Here, isn't it? And we are telling that to become y hat as 1, isn't it? To minimize the loss, isn't it? We want this y hat as 1 to minimize the loss to become 0, isn't it? To become 0, isn't it? But we can't change the weight of here to make this as 1, y hat as 1. So we can't actually make the discriminators any weight change to make it 1 happen, isn't it? But we can update the parameters of here. So what we are actually doing is we are blocking the words of here and we are telling the loss is telling to make this y hat as 1 as in 1, but we can't change this part as in this part, and we have to change the weight of this part, so it become y hat become 1 and our loss become close to 0. Our loss become minimized. So we have to this discriminator give some loss, and this loss give a signal or a gradient signal to the training of a discriminator. So this will provide some signal which is a gradient to the generator to update the weight of parameter of here. So why we are not just we are just giving the 120. The discriminator is not super intelligent, and the discriminator is not just, it is trained on 120 images, it is trained on sufficiently small data. So the training signals it will generate some loss, but the loss signal which is coming from the discriminator and so the feedback, this is also a feedback loop, guys. This is a feedback loop. So the feedback is not that advanced because it has been just trained on 120 images. The feedback is pretty basics and pretty, because it has just learned some primitive features or some, not a primitive feature, but it's not that advanced features, so that generator could learn. So it's just giving the required feature or required data representation. So the discriminator has also learned some data representation which is pretty basics, and the discriminator, because we are just giving the 120 image, it does not learn the whole data distribution. It learns some basics, little bit of amount of data distribution, how the data is and how the data actually looks, and what's the representation, what's the property, and what's the attribute of the data. And so it has discriminator, just because it has trained on just a small amount of data, it can't give the whole data representation and the attributes and the properties of the data. So it will just give some basic features which is needed for the generators generator training. So it will give some feedbacks. This loss will give some feedback to generator to update the similar basic features, and the generator will learn some basic features and some necessary features while at learning just basic things, and it will learn some learn from the signal provided by the discriminator, and it will update the weight accordingly. The signal provided by the discriminator, and it will update the parameters of the network. And the generator become little bit more capable. Now since generator has updated the weight, and this transformation function which has been which is been learning, we are just learning approximating this transformation function. So the transformation functions is this, which will take this random vector z and convert into this images. So we are just learning this function and the functions as a parameter of this generator. This is a generator is a transformation function. So this is the functions, and the function has the parameters of nearly millions of parameters. And when this 100 dimensional pass to the millions of parameters it will produce, it will just mapped into images. So we want to make the weights of the generators in the millions of weights to align in the direction when we pass this 100 dimensional vectors that will resemble the data coming from the real data set. We want to make when you pass this z, and when you pass to the generator weights, the weights and the vectors combined or just combined in such a way that it will then generate the images which will look like real. So how can you find these the millions of this high dimensional functions? So this transformation function contain millions of parameters. So when you pass this 100 dimensional vectors through this function which contain a million of parameters, this vector will combine in such a way that mapped in such a way that it will generate the real images. So there is we have to learn these parameters at its best values which will generate the real images. So we have to make the weights so that when it passes this vectors it will generate real looking images. So our main goal is to find this parameter. So guys, first of all we have trained the discriminator, and discriminator will become a little bit capable, and then we do not use this dataset training, and we will freeze the weight of discriminator, and we will start the generator training process. Generator training process start is with just passing this random vector and generating some noise image at the first, and passing to the discriminator, and discriminator giving some loss, generator loss, and just giving the feedback and updating the weight of generator and making the weights better and better. So and making these transformation functions even better. So guys, so we have learned this little bit basic things. We have to go even further to even capture the whole learning process of the GAN. So let's say we have trained the training signal has been come to the generator, and generator update the weight. After that, what we will do is we will give the generator images. Will train for batches. We will train this generator for one batch. For one batch we will train this is the generator, and after that what we'll do is if the generator starts using the signal provided by the discriminator and become better and better to finding better and become better and better for generating the samples which look real as the training data set. So our generator is become capable, and our discriminator is in this 128 image trained generator is not able to distinguish between the generated images and the fake images. So and our generator become little bit better, and discriminator we have trained it, so it is better. And now our generator can't learn much more of that, because it has learned the features which discriminator gives the signal which it has learned and it is become better, it is become little bit better from the feedback of the discriminator which has just be trained on these images. So after that, after training, after updating some weights here after updating some weights of generators it can't really give the other representation. So because it has just learned on few images, so we have to even train the generators the discriminator even more more. So after that, what I'll do is just train the discriminator once again from the both data generated from this, and this data will become much more better in the second discriminator training. Second time we'll training the discriminator. So 64 images better images in a previous than because it has been trained, so it will generate better images in a, so better noise we can say, not images because it's just a learning. So it will generate a better noise. So and this is the data which will be looking pretty real as in, it's because it is real. And when you pass through it the discriminator will even learn, and discriminator will even better become even better distinguishing between the real and fake images, because the noise is better than the previous noise, and discriminator will learn to distinguish between the real and fake. After 128 images seeing the discriminator, there will be some loss and there is a back propagation, and the discriminator weights updation happens and discriminator become much more better of understanding the data representations and the property of the images. So now so now our work is to train the generators. So at time and at the first time in the second time the generator generate images, and it will pass to the discriminator. It will pass to the discriminator, and discriminator will easily detect because it has been trained. So even two times on 120 images and 120 images, so it will tell the it will generate some loss. And we are just using this image while training the composite model, this generator discriminator. We are not using this when we are training the generator. We will not using this data sets images, and we will freeze the weight of here. So pass some images and discriminator will say this is fake images, but we say one we give the label as one, and so there is some loss, and this loss to be minimized. So our objective is to make y at as 1. So how can I make y at as 1? So try to update the weight in such a way that when this random vector pass to the generator will generate that images which look like the real images. So we are just this loss is just forcing the generator to learn the parameters and the weight which will make the random vector into a real looking sample. So in a way we are forcing, where this loss is the discriminator says and this is fake, so it will give the label as 0, and there is some loss 1 minus 0, there is some loss 1 loss or some losses in it. So we have to minimize the loss. So we can't update the parameters pure, and we have to update the parameters pure. And so we are forcing in a way we are forcing the parameters of this generators to make this 0 as 1 and so 0 as 1 means when we give the fake images the generator will say this is 1, and so we are forcing this generator to make the weights and biases of here in to obtain the values in which will when it take the random vector, it will generate the real images. So after that after that second training after the second training it will after the second training it will become even better. The generator will become even better, and it will try to learn the more detailed representation than the first time training the generator. So So the discriminator feedback will become much more better because discriminator has been trained, isn't it? So it has learned much more thing, and the feedback, isn't it? It will give some feedback, isn't it? So to the isn't not a feedback but loss, there is some loss. So we have to update the parameters. Uh, so we are just because it gives some signal. So this signal in the form of loss. So the loss, this signal helps, isn't it? The generator, isn't it, to learn more data distribution, data representations, and after that we will just repeat the process for many iterations, and until the generator become much more capable, isn't it? After that this discriminator will become much more capable, much more, isn't it, stronger when classifying the images, and the generator is become much more, isn't it, capable of generating real looking images, and listen, we are just making both of them, the discriminator and generator, both of them much more smarter, smarter, we are making the both them, to grow together, we are just trying to arrange the training so that they grow together, but the discriminator is one step ahead of the generators in this case. So because it's just like a reference, isn't it, which know a little bit of more than you, isn't it? So you are not learning from the teacher, isn't it? You are learning from the friends which know a little bit of more than you, isn't it? It has just seen 120 images more than you, isn't it? So because we are not training because they are learning, isn't it, of one simultaneously, they are learning both simultaneously, and this is pretty interesting as an observation in our life also, isn't it? If you see, isn't it, when your friend, isn't it, tell you the concept, isn't it, you can learn much more better, isn't it, than your teacher actually explain you things, because, isn't it, that's why, isn't it, because this is not so much the discriminator just learn much little bit of more than you, but uh, not not all, not all, it has not seen the whole images at once. Let's consider the 10,000 images, so it's better, isn't it? So it has just seen some wanted image more, the more, isn't it? We does not train the discriminator at once with the this whole images. I will tell why we don't do this, but, isn't it, uh, what is here is the concept is, isn't it, the discriminator is little bit of better than you, isn't it? Your friend is this is your friend who knows who know a little bit of more than you, because it has seen something, isn't it? So it will, like, this is not your teacher, isn't it? This is your friend, isn't it? Your friend, isn't it, which know a little bit better than you. So as I say, you, isn't it, you learn better from your friend than your teacher. Why I will give you, because the language, the context, the vocab, and the word and the language that you use to communicate with your friend is similar, isn't it? Similar. They are not. If you ask to the teacher, isn't it, teacher will use some different, isn't it, words and some different approach and context, isn't it, to understand the same concept, but, isn't it, your friend use the similar context that you know, isn't it, that your friend knows, isn't it, which you also know, isn't it? So it's pretty ideas and accents become much more easier, and so you can easily propagate the ideas, so pretty easily. So in that case, this is not a teacher, which know all these 100,000 images, not 100,000, 10,000 images. It's your friend, which know a little bit of better than you, and because as in real life, your friend is a little bit of known than you, when you are learning some concept, he will, give the context, that you are familiar, because he is familiar with that concept. So the feedback and the mentorship he will provide is better, than your teacher, so in that case, in the case of discriminator and generator is same, as in our real life. So, because when you train the discriminator with this 10,000 images at once, 10,000 images at once, you can't, give the signal about the data representation to the discriminator, because the gradients which will be flow from here is in the discriminator losses in the you can't make such weight updation is in because is in it's too far is in it's too much long the whole data distribution. It has learned everything about the data distributions and data properties. So is in the feedback will not be is in which feedback will not help the generator to generate realistic images. So at first when the discriminator is trained on this 120 images, the feedback will help with the weight updation to learn the data representation from the basics and understand the primitives, not but primitive but also some basic features in basic feature at first and then understand the better and so if you train this advanced discriminator the way the gradient will does not affect the gradient will be just ineffective is any to train the generator. So the this less train discriminator provide the gradients to the generators in a generator so that the gradients actually has an effect on the learning of the generator about the actual data distribution. So actually why we are not training the both is that's the reason is if we just train the whole network is whole discriminator network at once is the feedback will not help the discriminator generator to learn the actual data representation because this the if we this train full train the discriminator will give gradients which are ineffective for training the which are ineffective for generators to learn the from basic to the advanced data representation. So the generator has to the generator the generator needs the gradients which helps it to understand the data distribution as a whole as a whole and also and also it build up from basic to the advanced data feature or attributes. So that's why it does not train the both at once both of them at once. So this is the intuition about how we train the generators. So and we will run this process and repeat this process for this is in and I want to tell you that this is our 10,000 images and we will gonna go train in batches. So batch means and we have to define some batch sizes. Let's define the batch sizes. Batch size is 128. We just giving the batch size 128 means we are just sending the 128 images 128 images here during the training of this discriminator and generator. So means what we are whatever do it 128 we have the size and we have 10,000 images. 10,000 divided by 10,000 divided by 128 this is our batch per epoch this number will be batch per epoch means we have to run this time this is a batch per epoch. So in one epoch how many batch we are dividing. So this is our batch per epoch and this n number we will give the generator and the discriminator the data to train and we'll just give this because this is will not give the generator while this data. So this is for the discriminator. This batch is batches of images for the discriminator and also for the generator because it will generate its own data. So we doesn't have to give this 10,000 because it will generate it will generate 10,000 images when the discriminator requires. So So we will, so I will listen, just move to my computer screen and understand this concept in this batch size overall. So I will just give you the overview of the training through the code. Just I will just show the components and the training steps. So you can just see how it is implemented on Keras.